So I'm also talking about bugs. Unlike Aaron, I only have a picture of one bug. I will let you try to find it. This work is done with Jackie Chen, who's one of our undergraduate researchers at MIT. I'm Dr. Evan Patton. I'm the lead software engineer for the App Inventor project. I'm going to skip the agenda. For those of you who don't know App Inventor, but I imagine most of you do, it's a web-based platform for building your own mobile phone apps. It is the original Blockly project. It is the project that spawned Blockly because Neil saw how bad our original Blocks editor was. Over the years, since we switched over to Blockly, we've had 29 million users, pretty much every country and autonomous region on the planet, and they've created over 134 million applications with App Inventor. App Inventor comes from this real idea from Hal Abelson, our director, about trying to use programming to make real things that are useful for people, and that's how they're going to learn. As an aside, how many of you learned how to balance a checkbook? Yes? Some. I learned how to do that in the 8th grade. I wrote my first check when I was a sophomore in college. Right, so what was the useful, I mean, obviously it was useful, but I didn't see the applicability of it until much later. So the idea that you can build something that is important to you now and learn the process now in your own context is really important. So App Inventor's UI is really composed of 2 different pieces. There is a designer side where you drag and drop to put together the layout of your application. And then there's a code editor, which of course is built on Blockly. Now, we wanted to add debugging capabilities to App Inventor. And why would you want to do that? Well, we've been seeing, of course, as many of you are, the rise of vibe coding. And one of the things we expect is that we're going to need to give better tools to students to understand how the code is working so that if there are bugs that come up, they can try to understand how to fix them. So as an example, I made this very simple application. On the left side of the screen here, we have what the app looks like on my Android phone. And then we have some very basic code here, which I've added some stuff to just to give some idea of how you build this. And we have here introduced a breakpoint option. So you can set breakpoints on your blocks. The code will run on the phone. When it hits the breakpoint, it'll come back and allow you to inspect the state of the application. Can anyone tell me what happens at this breakpoint if I click the button? Any idea? Okay, no? A runtime error occurs. So that is the bug in my program. And why does that happen? Well, because the text box, I didn't put a default value in, so it's empty. And when I try to add 1 to the empty string, that's not a number, and so it gives you a runtime error to let you know you can't do that. Separately, like in JavaScript, you would get the string 1. Here, you'd have to actually use a different operator for that. So users have this happen all the time. This is a very trivial example because there's only 1 plus operator, so I can go back and I can find it. But if you imagine 100 blocks, and maybe you use 10 plus operators, you'd have to audit every single one. So instead, what we do is we actually will focus on the block to show them where the error occurs so that they can start to dig in and understand why that's happening. So we had 3 major things we wanted to do to try to solve this problem. First is we wanted to bring focus to where the errors are actually occurring. So in our code generation, we now have block IDs associated with every single operation so that we can bounce back and let the user know where in the stack they were when the error occurred. We wanted to make sure that the state of the app was inspectable. Again, you're getting real user input into your application. It's very different from, say, a unit test where you've defined everything well. And because users are very weird and they do lots of weird, interesting things, that means you have to be able to see what the state of the world is when an error actually happens. And of course, you might be getting things back. Maybe you get an error from a web endpoint, and then you have to understand what the error message is and what what the return values were and all that. And then lastly, we wanted to add stepping support to App Inventor so that you could actually step through your blocks and see everything happen as it was running on your phone. So we don't control our runtime environment for the most part, right? We're running on a mobile device. The operating system is doing a lot of work and heavy lifting to make sure that your phone continues to run well even when the apps behave badly. So one challenge we had in App Inventor is that all of our blocks are being executed on the main thread because they're doing UI updates and things like that. So we had to move that away because otherwise if we pause the world to try to do some debugging, the OS would be like, well, this app's not responding, so you lose. So that was step 1. App Inventor also has this really unique thing where we target Scheme as a programming language. I think we're probably the only Blockly environment that does that. But Scheme has a really powerful thing because it has full-blown macros in the language. So we actually just updated some of our macros on the phone, so that way we didn't have to worry about changing much of the code generation. One piece of code generation we did change, though, was using the scrub function in order to be able to add the block IDs, like I mentioned a moment ago. And then because we have lexical scoping in App Inventor for our variables, we had to add some additional metadata to track when variables were entering scope and leaving scope. So I'm just going to talk through a couple examples really quick, just to show you all these different pieces. So going back to our original example, we can now change it. So we saw that there was an error where we didn't have a number, so we can now check and say, if this is a number in the text box, then we'll do our math. Otherwise, we'll give the user an error message. Right? And that's much cleaner than just having the random pop-up that happens, and the user can understand how they're going to fix their program. Classic CS example, the Fibonacci numbers. So this is just kind of show you all the different pieces. We have on the right-hand side, many of you who have used, say, the dev tools in Chrome will recognize this structure. So at the top, we've got 5 buttons. We made them look a little bit more kid-friendly. So the first is the continue button, right? Just continue running the program like I would be doing normally. Then we have our step over, step down, and step up into the different blocks, which allows you to kind of go through the entire tree structure. Stepping over will continue to the next statement block, and you can step down and up through all the values. We show then the local and global variables, so we can get some information about the current executing state. So in this particular step that I highlighted, n was 1 in my function call, and we'll see in a moment the stack. But the other thing that it can do too is when you return from a function that gives a value, we will tell you what the return value was, so you can even keep track of the calculations as you go through. Again, App Inventor is running in an environment where the user is providing real input to the system. So in this particular case, because I was testing Fibonacci, you don't see any properties, but the idea is that if I type the number, say, into that text box, I would see the fact that I typed it in here, so I can inspect and see whether my components match what I think I should be getting versus if they're the default values. And then lastly, you get the call stack. Right? And so when you're doing recursive functions, especially like Fibonacci, you can actually go through the different levels of the stack frames and see how the local variables are changing from step to step of your program. So contributions to next steps, but before I do that, shout out already. I know Natalie spoke this morning, and we have a whole bunch of talks tomorrow from the App Inventor team on all the different projects we're working on over there. And definitely, I would say, for those of you who are still upgrading, I would promote Mike's talk on going from V11 to V12, and we're just talking about V13. So hopefully we'll be able to do that soon. And then we've got some interesting workshops on AI and coding in general in the future. But for our project here, we actually were able to do this. We have to do some studies still, so we're working on doing the study design. But we have the implementation available so that people can try it out, and we've been sharing that with our power users. We have now this tool that allows us to map all of the features of a real programming environment that people would end up using if they went to build a web page with some JavaScript. Right? All of those concepts now exist in App Inventor, so they get this very nice transition from our development environment into a browser development environment or Android Studio or Xcode. And then lastly, we're hoping, we haven't quite figured it out yet, how to generalize all of the different capabilities of the system so that we could publish it as a plugin. So if you have an execution environment where you can set breakpoints, that we would provide all the UI and everything like that, you could skin it and then make it available for your own Blockly projects. And with that, I think I kept us to a pretty good time. If we have questions, I'm happy to take some.
Hi, I'm Kier. I was wondering how you, if you ever run into issues associated with different target architectures. So, for example, if you make a Blockly program, you can verify if there are issues using your debugger. But are there any, sometimes there's problems once you actually put that code on some specific target architecture, there are bugs that don't exist on other ones, or is that not a problem? For example, like once you find out that there aren't issues in the JavaScript, does it just work across lots of different devices, or?
Well, yeah, so that would be the thing we're trying to figure out in this last step, right? So all of the changes we had to make for App Inventor's runtime, because it's Scheme, are very different from possibly other runtimes. So certainly with JavaScript, one might think that we could maybe run it inside of Node and expose it through the DevTools API. And then you just interact with the system that way. But we haven't quite gotten there in terms of running it on anything other than our existing scheme runtime. But if you're interested in working on something like this, I'd be happy to talk with you afterwards and try to collaborate.
Oh, sure. Thank you.